In this video, I'm going to cover CIS18A Unit 2, Part 3 lecture, which is Chapter 3. It talks about control statements. So to begin, there are three categories of program control statements. A selection statement, which includes if and switch. Second is iteration statement, which include for, while, do while. And lastly, include jump statements. This includes break, continue, and return. So there are three types of statement in control statements: selection, iteration, and jump. So for the beginning of this section, it provides you with an example, which is also included in the lab. This example shows you how you can read a character from a keyboard. And in this example, we have class KBN and we have a main method. Now for Java, we wanted to have those Java IO exceptions for input and output exceptions. Here on it explains this line particularly just handle Java exception or possible error for input and output. And inside the main, we have a variable called ch. It's type char, so it is to store one character. And for the next line, we would output press a key followed by enter. So we instruct the user to enter a character or press a key and then press enter. Then next we would have the character be read and stored to ch. So here, as you can see, we type it as char and we would do a system in read. That would basically, it would get the char and store it into ch. Then after that, we would output what the user has keyed in as a character. Your key is, and then we bring down ch, the value for ch here. So this program allows you to ask the user to enter a character, store that character to a variable, and then output what the user has entered by retrieving the character from the stored variable. So on page 21, it provides the explanations and also shows you the example program. For the next part, we're going to take a look at if statement. And in the last part 2 video, I touched a little bit on if statement when we're looking at the logical operators. So in this part, we will further look into how if statement works and how you can use if else. So the format of this is you would have if, and then in the parentheses, we would state the condition. And that will be your evaluation or your test expression. Your test expression can go into the parentheses. Follow that by the semicolon after the statement. Now with the else, you simply have the else and then the statement and finish that with the semicolon. So with the if condition, with the if statement, it's going to check for the condition is true. If it's true, it's going to execute the statement. If it is not true, if we're using if else, then it's going to go to the else and it's going to execute the else statement. So if would only execute if the condition is true, then the statement is executed. Otherwise, we would go to else and the statement following else will be executed. So this is a general form, and for the general form with the block, we wanted to have the curly brace following the if condition, and when we finish that, we want to close out the curly brace for the else condition. We want to finish that with the curly brace. So conditional expression controlling if must produce a Boolean result, and that is important to note. So if checks for the true, and else would execute if the condition for if is not true. This example program is a little game for guess a letter. So the class here is guess. We have a main method, and here we have Java IO exception, and we would recommend using this to catch error in the case if there's input error. So char is the type for CH, and the answer is K. So char answer is also type char, and it is initialized as K. We would then output, I'm thinking of a letter A through Z. Next line we would output, can you guess it? And it's gonna wait for the user to key in a letter and then type that as character, store that into CH. It's gonna read the char from the keyboard. Once the user enter that, it's gonna check to see if it's right. So if the key in value that is stored in CH is the same as answer, which is K, it's going to output right. If it's not, right, this program doesn't have the else statement, so we want to also extend this program to have the else statement to output wrong if it's not the same as the answer. So the example program needs to be extended, as you can see, as it's only including the if statement. If the user key in anything else outside of that, it won't be able to provide any output as it doesn't contain the else statement. So here is on page 23 in the guess2 program actually have the else statement. Sorry, you're wrong. So to extend from the first program, we have the second program that would have the else statement. On page 23 also provides you with the explanation for nested if. And so here the nested if is the if statement that is target of another if or else. So the main thing to remember is that an else statement always refers to the nearest if statement that is within the same block as the else statement and not already associated with an else. So here's an example. We have if I is equal to 10 and if j is less than 20, a is equal to b. If k is greater than 100, c is d. Else a is c, so this refers to the if for k is greater than 100. Else a is d, this refers to I is equal to 210. So this outer else right here refer to this if. This else right here refers to the closest if here in the block. Okay, and since Java doesn't require indentation, but you should still indent to make sure that the block is readable and it's visible so that way when you troubleshoot your program, you don't get confused. So as we see here, we would indent accordingly the if with the outer else, the inner if as it is nested, and then another if with the inner else. And to further extend that program with the nested if, we can see that the nested if is added to the guess2 program and make it guess3. So we have an if else here, originally for guessing the answer from the user. And if the key in value is not matching, it says sorry, you're wrong. So then we would nest the if, and notice that we would indent here, would say if CH is less than the answer, we would say it's too low, else we would say it's too high. So the else here is referring to the nested if that's nested within the other if up here. So we can have the nested if added like this. And we can also construct it this way. We would have if condition statement, else if statement, and so we would have a ladder of if, else, if. And from top downwards. So a good example for this is on page 25. So here we have a class called ladder. Inside that class we have a main. We declare a variable called int x. And in this, what we have is we have a for loop with the nested if else. So in the for has three parts: where we start, where we end, and how we want to update. So we start at 0 for the for loop, we go up to 6, and we want to update by adding 1, we increment. And within the for loop, we have a nested if else. So we have if x is 1, it would print x is 1. Else, and again we would nest another if, so else if x is 2, it would print x is 2. And then we have a third level of nested else if x is 3, print x is 3. And then lastly, we have another nested else if x is 4, print x is 4. And then lastly, the else to finish, to complement the if from the top. So we have else, we would print x is not between 1 through 4. And this is going to be the default statement. So with that, as you open your curly brace for these, we would have to close them. So we have 3 open curly brace. We close the 3 curly brace. Then here is the output. And so I recommend that you test this example program so you can see how the nested else if can be used within the for loop, so you can have a better understanding. Next, I want to explain switch statement. And commonly you would implement switch statement for when you provide options, or we would be able to branch in multi ways. And so it would allow your program to have different alternatives. So for example, for the course project, many students would use switch statement to provide customer options. Option 1, 2, 3, 4, possibly for restaurants or gym or different types of business. And so the value of the expression is successfully tested against a list of constants. So we would have option 1 as case 1 and option 2 as case 2 and so forth. So in the general form, we would start with switch and then have the expression in the parentheses, then follow that with the case and each case statement. For at the end of each case, we would have a break statement. So here is case 1, and following case 1 statement, then we would have a break, and then we would go into case 2. It's case 2 statement and then a break. So after each case, you should include a break. And then lastly, we need to have a default statement sequence. And here it gives you a little bit of legacy information about the older JDK. So something that we need to take away from switch, that each of the case statements needs to have a unique constant expression. It cannot have the same constant value, such as a literal value. Second, duplicate case is not allowed, right? It would throw an error in such case. Third, the type of the value must be compatible with the type expression. We cannot have mixed type there. Fourth, no case constant if there's no case constant matches the expression, the default statement sequence is executed. So if it does, nothing is matched, then it's going to kick it over to the default statement. Next, when a match is found, the statement that's associated in each case, as you saw earlier, following each case, is then executed until the break is encountered. So you might have multiple statements underneath each case, and in the format here, I'm only including one of the statement sequence. You can have many statements there, and then when it reaches the break, it's gonna get out of that case and it's gonna go to the next case. Or in the case of the default, which is gonna be the last case. So the last case should include and follow that with the default. So here's an example of a switch program. So this is one of the programs that I had included in the lab, so you can see that way you can implement it in your future project if needed. So in this one, we have switch demo as a class. In that, we have a main method, we have int I, we have a for loop, and this is nested within a for loop. So with the for loop, we talked about having 3 parts: where you start, where you finish, and how you update. So with the switch, we have different cases here. As you see, it doesn't have any repeat. So case 0, it show I is 0, case 1, I is 1, case 3, 2, and 3, and 4, and so forth. And then at the end, we have a default following the last case. And this is the last case, so default, and I is 5 or more. So here's the output for that. And as you notice, also again to remind you, that break is at the end of each case. And then the default doesn't require a break. Okay, so the break statement is optional. However, the break statement causes the program to flow and to exit from the entire switch and resume to the next statement outside of the switch. So all statements at at the following matching case will be executed until break occurs or break encountered. So for the test and the assignment and the quiz, make sure you know when to use the break statement, what it's used for. That's essential. On page 28 shows you an example of how you can nest switch statement. And again, we wanted to have indentation so that way we would see the flow of the nested switch cases, and it's easier for you to troubleshoot when you look through, especially when you're working with how to fix some of the cases in the switch. And on the same page, you would see how a for loop, a general form of a for loop, and how it's written. So like I mentioned earlier, there are 3 sections in a for loop, and it needs to be separated by a semicolon, and that's important to know. It would continue to execute as long as the condition is test true. So for the for loop, it's gonna test for the condition. If the condition is tested true, it will continue to loop and it will count up. Then when it reaches a false state, then the loop will exit. So the program will execute as long as it's true. The loop will occur as long as it's true. And then once it exits, when the condition is false, it would exit, and then the program would resume with the next statement. So here is an example of a for loop. This is an example of a square root. So we have a class square root main method. We have 3 variables, num, sroot, and RERR. And they are all type double. We have a for loop. Remember that there are 3 sections to the for loop. Num, where we start, and here we use num as a variable inside for the 3 parts for the for loop. Num starts at 1, and it's gonna finish at 99. It's less than 100, so it's gonna finish at 99, and it's gonna update by incrementing up. So sroot's gonna store the square root of num. So we would start at 1. So the first round, it's gonna do a square root of 1, and it's gonna print square root of 1 is 1. And then it's gonna go up again to 2, and so forth until it gets to 99. Now the second part of this program is to compute the rounding error. So RERR here is going to store num subtract the square root times the square root, and then it's going to provide us with the rounding error as the output. So as you can see here how the for loop is written, and again the 3 sections are separated by the semicolon. So the textbook and also the notes provide you with the example on how there are variations of the for loop. And so we can have an update to increment, an update to decrement. There are 2 ways that we can have the loop control variables. So in this example on page 30, it's using a for loop, And in this example, we have class 4 tests, main method. And since we're taking the input, we wanted to have Java.io exception. We have a variable declared as int I. I is used inside the for loop. So basically, we output to the user, press S to stop. And in our for loop, we start at 0. And it's going to, for the system in read here, it's going to wait for that S. And if it's not equal to S, then it's going to keep going. So at the end, we would have the output pass hash, and then we would have the variable I here. So in this can be used as a way that we can control on how it would wait to read the S key from the user input. And for the next part, here is a little note on how you can have an infinite loop and a loop that never ends, it never exits. So if you leave the conditional expression empty, that's an intentionally infinite loop. And we would also revisit this with the while. Now in Java, the body is associated with a for loop can be empty, because null statement, it is valid, but that would just be a bodiless loop. So here is an example on how we would have no body for this loop. There is a for loop statement, but there's nothing to follow that. However, it's not recommended by practice. So it's still executable, as you can see as the output is shown on the next page. Okay, so next we're going to talk about how we would declare a loop control variables. So here, notice that you can have that. Earlier we had the int I declared at the top, but we can also declare it within the for loop. So the variable I is declared inside the for loop statement here. Compared to the last program, we have int I declare above it. So this is a way that you can also declare the I within the for loop. But when you do that, the I is only usable, it's only known inside that block. Its scope is inside that block. So that means that I is not, cannot be used outside of that block. Okay, so if you intend for I to be used outside of that block, then you would declare it above that, within the main, so that way it will be known to the rest of the program within main. Okay, so on the next part, I'm going to talk about while and do while, and that would wrap up our control statement. So while the structure for while is like this: while with test condition or test expression and its statement followed by the semicolon. So here's an example for while. For the while statement, the loop will continue as long as the condition is true. When the condition becomes false, the program would then immediately resume back right after that loop. So it's going to pick up to the next statement. It's going to exit the while loop, and it's going to continue immediately following the loop. In this example, we have a while demo class. Within it, we have a main method. We have ch as a variable. It's type char. And we're using the while loop to print the alphabet from A through Z. So the first variable here is ch. It's declared. Then we would initialize it as A. Then we begin our while loop. While ch is less than or equal to Z, then we would print out the characters. So it's going to start at A, and it's going to go B, C, D, E, F, G. So as it increment up here, you can see. So it's going to go to the next letter, and so forth until it reaches Z, and then it's going to exit. So this is a simple program to show you how you can print the alphabet A through Z using a while loop. And notice that we assign the start here, so you want to assign the value where it would start, and then we would have the while statement, and then we would follow that up with how it updates or counter in the last part. Okay, so that's a good example for the while loop. You can test that example and see how it works. So here, note that the while checks the condition expression at the top of the loop, which means that the loop code may not be executing at all. This eliminates the need for performing separate tests before that loop. Here's another example of using while, but this one, it's actually nested within the for loop. So we have the class power, main method. We have two variables, int e and int result. We're using the for loop. It starts at 0, go up to 10. And what we're doing is with the while, as long as e is greater than 0, we would multiply our result by 2. So that way we would start here at 0, so 0, 1. So it's going to take 0. It's not going to test true here, so it's going to skip 0 times 2. We would have 1. 1 times 2 is going to give you 2. So with that, what we have is we would have 2 to the power of, and we would store it as the result. So here is 2 to the power of 0 is 1. And then 2 to the power of 1 is 2, 4, 8, 16, 32, 64, and so forth. So when it gets to 9, as because our for loop, we have it stated that it's less than 10. So when it reached 9, that will be the end. That will exit the for loop. So this is why you see that 2 to the 9 is 512, and it would finish there. So this is an example of a for loop with the nested while. Lastly, we're going to talk about a do while. And unlike the for and the while loops, the do while loop checks for its condition at the bottom of the loop. That means that the do while loop will always execute at least once. Okay, so it would do at least once. And if it's not, then it would exit. If it's not true, then it would exit the loop, but it has to execute at least once. Now, So the general structure of the while is like this. General form is do, and then follow that with the statements, and then you would have the while, and then inside the parentheses we would state the test condition. So the do while would execute as long as the condition, the test expression is true. So if the test expression is false, then it would exit the loop. Now, here's an example of a do while. We have class DW demo, we have a main method, and we have a variable called ch that's going to store character as its type char. We have a do while statement. Do, we would prompt to the user, press a key followed by enter. So then ch is going to listen and store the input of that character, while ch is not q. So it's going to check to see if ch is not q, and it's going to keep going as long as ch is not q. So if the user press q, then it's going to exit out of the loop and it's going to end the program. But if the user press any other letter, it's going to keep prompting the user to press the letter. And here is the guessing letter game, as what we've seen with using the other loops, but in this case we're using a do while. So we have a do while nested with an if else. And so for the do, we ask the user to input the character. Then another do to discard other characters of the input. And then the if else statement to check to see if the input is matching what we had stored, which is the letter K. If it matches, it would be right. Otherwise, it would show that it's wrong. And on the outside for the while, if the answer is not for CH, then it would keep prompting the user to enter the letter. So this is another version using do while compared to what we've seen previously using for and while loop for the game, and just if else. So the explanation of how the breakdown of the program you can also find on the bottom of that page there, on how the while and the do while is used. So earlier we talked about switch and the break statement. Again, I wanted to mention that you will find some questions on quiz and test related to break and continue, so make sure that you go through the section. Here it talks about break statement is encountered in the specific example here, and so if the break statement is encountered inside a loop, like what we seen earlier with the switch, or in the case where if we have a for loop here and we can force it to break, so the loop is actually terminated as soon as it's encountered, and the program will revert to the next statement and go through the next statement. So here is an example of that. We have a for loop with the nested if, and then there's a break, so it terminates that loop and it would resume back to loop complete. So another example you can see and the explanation of that on page 36. So the two things that we need to also focus on when we work with break statement, if you have more than one break statement appear in a loop, too many break statements can destructure the code. So that's something that you need to think about when you're using break statement. And break statement terminates a switch statement affects only when if the switch statement that is not enclosed in other loops. So now for Java, Java does not use goto statement compared to C++. And however, goto can be useful in the case where it's deeply nested, but Java doesn't use that. You can use break with a label, and a label is just a name that identify a certain section of the code or a block of code. So you can label the block by giving it a name, and as long as you use a valid name that's not a keyword, that's acceptable as the identification, then you should be able to use the break with the label. So to see an example of that, see page 38, where we would have the label 1, 2, 3, and then you can have break 1, 2, and 3. So you can use a label like this, and just following the label with the colon, the label name with the colon, that will indicate that it's a label. And you can use once you have the label declared, then you can put it in next to the break statement. And the last part's going to be continue. So continue statement forces the next iteration of the loop to take place, and it would skip the code between itself and the conditional expression that controls the loop. So here is an example of a program using continue. We have const demo as class. We have main method within that class. And here we declare int I to be used with the for loop. And so this loop is going to go up from 0 to 100. And inside the for loop we nested an if I mod 2 is not 0, continue. So it's going to iterate, and it's going to print out the value of I. So now here the continue statement will cause the control to go directly to the expression and then continue the looping process. So another example is to follow that, and in this one we have a nested for loop, and in the inner for loop we have a nested if. So this one we have a class with the main method. On the outer loop we're using a label outer loop here, and we have a for loop. We're going to start at 1, go to 9, and we're going to increment. So it's going to print out outer loop pass each time it starts at 1. So 1, 2, 3, 4, 5, up to 9. And on the inner for loop, it starts at 1. Again, it's going to go to 9. And with the if condition nested within, it's going to make sure that it checks that if it's true. If j is equal to 5, it's going to continue to the outer loop. So it's going to jump to this outer loop here, and it's going to go through the outer for loop again. Now, if it's not, then it's going to resume back out here. So as you can see, this is a good example of showing you how to use continue with the label. And in this program, we're using nested for loop and if. So take a look at that program. You can test it if you wanted to explore on how to use continue with the label. And toward the end, there are various examples on how you can use nested loops, like the last example we looked at. Similarly, that is also being used for the next one, the next section, which is the nested for loop, and it shows you how you can find factor of values starting at 2, and it's going to go up to 100, which is going to give you a factor of 20. So that is a good example for looking at the nested for loop with the also a nested if for the inner for loop, similar to what you've seen in the prior example when we were talking about the continue statement. This concludes my part 3 of the video, which talks about control statements. We started with if, else, nested ifs, and then we have gone into for loop, while, do while, and we also cover continue and break. And so that would cover chapter 3. And if you wanted to look at the example and cover the content a little bit closer, you can refer to the notes and also the chapter. Thank you very much for viewing this video, and I'll see you in the next video.